And to finish 2.3, let me add a way in which you can calculate the range and the null space of a matrix using Gaussian elimination. Okay, so you could, after learning this, you can go back to 2.2 and do lots of problems calculating the range and the null space. So to calculate the null space of a matrix A, remember that you had to solve the system A times X equals 0. Okay, so that's exactly what you can do doing Gaussian elimination. You write your augmented matrix with all the elements of A and then zeros. Yeah, you do the Gaussian steps and you get to the row echelon form with zeros, and then you solve for X, and what you get is that some of these columns, some of the columns of U don't have pivots, and they are free variables, and therefore your solution X will be the free variables times some vectors. So alpha times a vector plus beta times a vector with as many columns as many variables that are free as you need. If there are no free variables because all the columns have pivots, then the null space is 0, and this means the nullity of the matrix is 0. Yeah, it's a 0-dimensional point, which is the origin. Okay, this is how to calculate the null space. As a note, remember that when you solved AX equals B and you did Gaussian elimination and so on, your final solution was still, you can also use it to calculate the null space, because what you had was X0 plus alpha times a vector plus beta times a vector, and this is the same null space as this. Okay, so once you have solved a system, even if B is not 0, you still can get the null space from it. Okay, how to calculate the range of a matrix A? So the range of A is equal to the span of the columns of A that are linearly independent of each other. And how do you know which columns are linearly independent? Because those are the columns which have a pivot in row echelon form U. So after doing row echelon form, you find the columns that have a pivot, you remember the number, so the second and third columns have a pivot. So you go to matrix A, and the second and third columns of matrix A, the span of those columns will be the range of matrix A. And that's because all the other columns which have a pivot in row echelon form are linearly dependent of those two columns that do have a pivot. Yeah. So the columns that don't have pivot are linear combinations of the columns that do have pivot, and therefore the span of the columns is equal to the span of the columns that do have pivot. Next, let's do an example, and that will finish the chapter.